It's long been a fantasy of sci-fi buffs and scientists alike. High-speed space travel, a little like this.
Warp drive, Mr. Scott.
Ahead warp 1, Mr. Sulu.
Accelerating to warp 1, sir.
Well, it seems that warp speed might be possible thanks to Einstein's theory of relativity. It's all going to be revealed today in a National Science Week talk by astrophysicist Professor Geraint Lewis. And Professor Lewis joins us now from Sydney. Professor, good morning. Thanks so much for joining us.
Good morning.
Look, it's an amazing thing to talk about, you know, hyperspeed or warp speed or the like. What is it, and is it really just not a fiction?
No, it's actually part of Einstein's theory of relativity. If you look at the equations that Einstein gave us, it shows how you can bend and warp space such that you can travel at any speed you like in the universe.
That's theoretically. How do you actually put that into practice?
See, that's the hard part.
Yes, I'm sure.
Yes, theoretically it's possible, and the big question we have now is it actually something we could physically realize? Could we ever build a warp drive? And we have hints that the kind of materials we would need exist in the universe, but whether or not we could ever get them together and build a warp drive, we still don't know.
Why would you want to build a warp drive?
The big problem we have is that the speed of light, while fast, 300,000 kilometers per second, the distances involved are immense. So even traveling at the speed of light, it would take 4 years to get to the nearest star and 2 million years to get to the nearest large galaxy. So this would stop you basically colonizing the universe quickly and rapidly traveling around. So you would need some sort of way to beat that speed limit, and Einstein's general theory of relativity gives it to you. All
right, so tell me practically then, how would the machine be built? I assume you're not going to be using rocket thrusters as we do traditionally at the moment with the way that we get around the galaxy.
That's right. So you need a material called, it has a negative energy density, which sounds very bizarre. It's not a material that we actually have in our hands, but there are signs that there are aspects of the universe that have this kind of property, that actually empty space itself has a negative energy density. The big question we have is if we could ever mine it and shape it, then we'd basically have a warp drive there and then. But we just don't know at the moment if that's possible.
Geraint, I feel like our conversation is in warp drive this morning itself. We're after a material that we don't have, that we suspect might exist, to be put into a machine that we haven't designed yet in order to travel at a speed that's only existed theoretically.
Absolutely, and that's science. I mean, that's the way it works. There's plenty of science that starts off as speculative ideas and becomes real in the future. You have to look at the work of Newton 400 years ago, and even people working in quantum physics 100 years ago, and those things are real things today, and they started off as dreams, essentially.
So in a sense, it really doesn't matter whether we build this spacecraft or not. It's about inspiring younger generations to embrace science and to embrace research?
Absolutely. Einstein's theory is 100 years old, but we've only started to scratch the surface. I think that, in the next 100 or 1,000 years, we're going to basically reveal a lot more about the universe, and maybe this hyperfast travel will be realizable.